Okay, so once again, good afternoon, everyone. So this time our topic is about compound interest. So we came from the simple interest, simple discount. So this time we may try to upgrade our understanding when it comes to mathematics of investment, particularly in what is compound interest. Now, so from the term itself, compound interest or compounding interest, is the interest on a loan or deposit calculated based on both the initial principal. Again, initial principal. Let's say, for example, you started to deposit 10,000. Later, I will give you a lot of example. Initial principal and the accumulated interest from your previous periods. So, thought to have originated in 17th century in Italy. Compound interest can be thought as an interest of interest. Okay, and it will make a sum grow of a faster rate than simple interest, which is calculated only on the principal amount. Again, when we say simple interest, we just simply calculate, let's say, kung 1% or 10%, that is 0.1, with the principal. So let's say 10,000. So the 10% or 0.1 only computed on the 10,000. But when we say compound interest, so let's say 10,000 plus your interest, then another interest for that. That is called compound. And later on, I will give you a lot of examples. So the rate at which compound interest accrues depend on the frequency. Again, frequency of compounding, such that the higher the number of compounding periods, the greater the compound interest. Thus, the amount of compound interest accrued, let's say, for example, on $100 compounded at 10%, annually will be lower than that on $100 compounded at 5% semi-annually over the same time period, because the interest on interest effect can generate increasingly positive returns based on the initial principal amount, because compounding has sometimes been referred to as a miracle of compound interest. Okay, so to give you an example of a compound interest. Now, before I'll give you an example, I'll just want to play a video presentation of your classmate related to compound interest. Okay? So if you have some questions, do not hesitate to post your question in our chat box, because our presenter is present today, and she will be able to handle all your questions. Or if you have some additional inputs, do not hesitate to post in our chat box, especially for those who are presently working in a bank. Maybe you have an idea already of, let's say, for example, you are working, let's say, for example, in like Palawan and any other same type of business. Maybe you have an idea, a broad knowledge on how you'll be able to apply the simple interest, simple discount, and of course the compound interest, as what we discussed today. Okay, so again, I just want to play the video presentation of your classmate.
Compound interest, meaning interest on interest. It is a little bit more functions and exponents. And that is the regulator, specifically yung cycle, yung scientific calculator. So let us ito yung formula ni compound interest. A is equal to P, open parenthesis, 1 plus R over N, close parenthesis, raise fundamentals when it comes to exponents like that. You have to follow kasi yung rule ng PEMDAS or yung order of operations, kung natatandaan nyo pa. So, ano nga ba ibig sabihin ng mga letters na ito? A is the total accrued amount, same thing din sa simple interest na si A din ang gamit. Ito yung result kapag time, siya yung pinaka-total. P is the principal amount, basically ito yung kung ano yung pinuhunan mo. So, plus, so open parenthesis, 1 plus R. Ano ba si R? This is the rate of interest. Ito yung percentage. Over N, number of times the interest is compounded in a year. For example, nag-invest ako ng 10,000 pesos with the interest rate of 10% within a year. So, magkakaroon ako ng 11,000 pesos after a year, or sa susunod na taon, kukunin natin ulit yung 10% ulit. Hindi na dun sa 10,000 pesos na initial investment mo, kundi dun na sa 10% na kabuuan ng pera mo within that year, yun yung 11,000 pesos na, hindi na yung 10,000 pesos. And so, when your interest is applied annually or once a year lang, yung N mo would be 1. Kapag quarterly naman, kasi quarterly, so ibig sabihin nahati siya sa 4 within the year, So 4 siya. Semi-annually, that would be 2. Ayan yung mga isa sa mga kailangan natin tandaan. And T, time period naman. So, kunyari sa isang taon, 4 na beses ka nag-apply ng interest quarterly, pero 1 year mo lang iniwan yung account mo, your T would be 1. Kung 5 years naman, magiging 5. Ganun yung bilang ni T. So, that is the formula you need to remember. Kasi ito yung gagamitin natin along the way ng discussion. As much as possible, you need to memorize it. Sample question number 1. An initial deposit of 100,000 is made into a savings account that compounds 5% interest annually. How much is the account at the end of 5 years? So, given na si, ang hinahanap natin dito si accrued interest. Si principal is given na, which is 100,000. Then si R is 5% interest. 5% or 0.05 na lang. Then, si N is 1 year kasi sinabi dito annually, which is mean 12 months, so 1 year. Then, si T is 5 years. Ito siya, 5 years. So, gagamitin na lang natin si formula. I-fill up na lang natin siya. Ito yung formula na kailangan natin kabisaduhin kapag kinukuha natin si compound interest. Yan, A is equal to 100,000. 1 plus 0.05, which is the value of R over N, which is 1. Then raised to 1 times 5, yung NNT dito. So, alam naman natin lahat na kapag numerator, denominator is 1, automatic maging 0.05 na lang to. Then, ang kailangan natin sundin is yung PEMDAS. Yung nasa loob muna ng parenthesis yung gagawin natin bago yung nasa labas. So, ito na nga siya. Si 0.05, inad natin siya kay 1, kaya siya naging 1.05. Tapos, yung dalawang yung exponent, pinag-multiply na natin siya, kaya nakuha natin itong 5. So, kapag sa exponent, ang kailangan natin gawin, si 1.05, multiply mo siya ng 5 times sa sarili niya. Kaya 5 to. So, 1.05 times 1.05 times 1.05, 5 beses. Then, makukuha natin si 1.28. Tsaka mo siya i-multiply dito ka 100,000. So, makukuha natin for A is 127,628. More complex question, which is question number 2. Sabi nga dito is that after 5 years of 4% interest compounded quarterly, an account has 61,009.502. What was the original deposit amount? So, ang hinahanap natin dito is yung principal. So, ito na yung mga given. Si A, which is ito yung total na pera after ng lahat-lahat na nangyari. Ito yung 61,009.502. Then si P, yung principal, yung hinahanap natin. Si R, which is yung 4% interest. Tapos si N, 4 years, kasi sabi dito quarterly. Pag sinabing quarterly, sa isang taon nahahati sa 4, kaya siya 4. Then si T, yung given time, which is 5 years. So, gagamitin ulit natin yung formula natin, which is A is equal to P, open parenthesis, 1 plus R over N, close parenthesis, raised to NT. So, i-fill up na lang natin siya. So, si 61,009.502 is equal to P as is, kasi siya hinahanap natin, open parenthesis, 1 plus 0.04 over 4, close parenthesis, yung exponent natin, which is yung NT, equivalent siya kay 4, so 4 times 5. So, ganun ulit, yung rule ni PEMDAS yung susundin natin, unahin natin yung nasa loob ng parenthesis. So, i-divide muna natin to, si 0.04 over 4 kay 4, equivalent niyan is 0.01. Tapos sa exponent, i-multiply na rin natin silang dalawa. 4 times 5, kaya naging 20 siya dito. So after that, usually talagang sa loob pa rin, yung loob pa rin ng parenthesis, kailangan natin tapusin. So si 1 plus 0.01, pinag-add mo sila, magiging 1.01, tapos raised to 20. So ganun ulit, 1.01. So madali talaga nga ito kung may cycle kayo. Kasi may exponent na doon na pwede mapindot. Kaysa pag sa calculator, paulit-ulit niyo siya ipipindutin na 20 times. So, magiging 1.22 siya. Tapos para makuha natin si P, yung rule nga, 'di ba, sa algebra dati, kailangan natin sila i-divide both sides by 1.21. Para dito sa side na 'to, ang maiiwan lang is si P. Mako-cross out na 'to. Tapos si 61,009.502, i-divide mo siya kay 1.22. So, si P, makukuha na natin, which is 50,000. And that is all. Thank you po.
Okay, so thank you very much for our presenter. So I'll just want to share with you additional video presentation with example, no, for you to understand more. Actually, our presenter could give justice naman actually with her presentation, but I just want to give you some additional inputs. No?
On compound interest. Before we can talk about compound interest, we need to talk about simple interest. Interest is the amount of money that we get paid if we invest a sum of money in, say, a bank account. It's also the amount of money we pay if we loan a sum of money from somebody else. Now, if we want to calculate our amount of interest, or the simple interest, we can use this formula, I is equal to PRT. I is our amount of interest. P is our principal. Now this principal, this is the amount of money that we originally invest, or that we originally loan. R is our interest rate. Now usually you get interest paid as a percentage of the initial investment or the initial loan. So R, this interest rate, this is usually a percentage. If we had a 5% interest rate, when we plugged in 5% into this formula, we would plug in the decimal version of 5%. We would plug in R is equal to 0.05 in this case. T is time, typically in years, sometimes it can be in months or days. Usually when we talk about simple interest though, T is just equal to 1. So let's look at an example. Here Joseph buys a new home using an interest-only loan where he pays only the interest on the value of the home each month. The home is valued at $200,000 and Joseph pays 5% interest per year on the home. So how much is his monthly interest payment? Well, we're going to use our simple interest formula. I is equal to PRT. In this case, our principal P, this is the initial value of the home loan, which is $200,000. R is our interest rate. This is 5% per year, or 0.05 per year. But we want to know how much his monthly interest payment is. Well, we have two options. We can either divide this 0.05 by 12, because there's 12 months in a year, to find out the monthly interest rate, or we can calculate the amount of interest we pay per year and then divide it by 12 to find the monthly interest payment. I'm going to leave our interest rate as 0.05 or 5% per year. I'm going to say that T is equal to 1 or 1 year, and I'm going to plug all this stuff into this formula. So I is equal to 200,000 times 0.05 times 1. If you calculate all this out, this is equal to $10,000. Now, that means Joseph is going to pay $10,000 per year on the home. But we want to know how much his monthly interest payment is. So, assuming he pays the same amount every month, we can take this $10,000 and divide it by 12. If we do that, we'll get $833.33. So, Joseph is paying $833.33 every month for his home. Now let's look at another example. Here Anthony puts $10,000 into a savings account that pays interest every month at a rate of 1.8% per year. How much money does Anthony have after 1 month? And if he leaves his original investment and the first month of interest in the account, how much will he have after the second month? Well, let's deal with the first month. We're going to use our simple interest formula, I is equal to PRT. Now our principal, or our initial investment, that's $10,000. Our interest rate, R, that's 1.8% per year, or 0.018 per year, but we get paid interest every month. So we need to find our monthly interest rate. So I'm going to take this 0.018 and I'm going to divide this by 12. If I do that, I'll get 0.0015. This is my interest rate per month. Now we're only worried about the first month of the investment, so T is equal to 1, or 1 month. And if we plug all this in, I is equal to 10,000 times 0.0015 times 1. So in the first month, Anthony is going to earn $15 in interest. How much money does he have after 1 month? Well, 15 plus the original 10,000 gets us $10,000 and 15, so $10,015. So now that Anthony's got $10,015, he's going to leave the $10,000 and the 15 in the account, and he's going to earn interest on all of it in the second month. So for the second month, our principal now is $10,015. Our interest rate for that month doesn't change. This is still 0.0015. And the difference in time between month 1 and month 2 is just 1, so 1 month. And if we plug in again, I is equal to 10,015 this time, times 0.0015, and then times 1. And in the second month, we're going to earn $15.02. So the total amount of money Anthony has after the second month, well, we add 10,015 to that, and we'll have $10,030.02. What's important to realize here is that in the first month, Anthony got paid $15. In the second month, he got paid $15.02 in interest. And this 2 cents comes from the fact that he got paid interest on both the $15 and the $10,000 from the month before. Whenever you get interest on interest you previously earned, this is called compound interest. Imagine that we wanted to find out how much money Anthony had after 30 months. Well, we would not want to calculate the interest for month 3, and then month 4, and then month 5, and so on. That would take too long. So instead, we're going to need a compound interest formula. Our compound interest formula looks like this. Here we have A is equal to P times 1 plus R over N to the NT power. A is our future value, or the final amount in our account, or on our loan. P is still our principal. This is our initial investment. R is the interest rate, as usual. N here is the number of times we compound in 1 T. So if we compound every month, and time is measured in years, well then N would be 12 because there are 12 months per year. So N is the number of times we compound in 1 unit of time, whatever we're measuring our time in. So let's try an example. Here Matt is saving for a new car. He invests $5,000 into an account that pays 3% interest a year. and it's compounded monthly. How much will he have after 5 years? So we're going to go to our compound interest formula. A is equal to P times 1 plus R over N to the NT power. We want to know how much he will have after 5 years. So we're looking for A. We know our P. P is our initial investment, which in this case is $5,000. R is our interest rate, which is 3% per year, so 0.03. N is the number of times we compound our interest, which is monthly, and our interest is in 3% per year. So since there are 12 months in a year, our N is 12. And we're going to invest for 5 years, so T is equal to 5. If we plug all this in, A is equal to 5,000 goes in for P times 1 plus 0.03 over 12 to the 12 times 5 power. So A is equal to 5,000 times 0.03 divided by 12. This is equal to 0.0025. Now if I add that to 1, I end up with 1.0025, and this is to the 12 times 5 power, or the 60th power. If you take 1.0025 and you raise it to the 60th power, this is equal to 1.1616. Multiply that by 5,000, and the amount in our account is $5,808.08. So this is the amount of money that Matt would have investing in an account that is compounded. Remember, that means we're paying interest or receiving interest on top of the interest that we've already received. If I were to plug this into the simple interest formula, I is equal to PRT, well then I would be equal to 5,000. R would be equal to 3%, so 0.03, and T would be equal to 5. Solve this, and I is equal to 750. If you were to add that to the 5,000 that we originally invested, we would end up with $5,750. Notice that this is less than this, because here our interest each year or each month is not being paid on the interest that we previously received. So it's always better to invest in an account that's compounded, if you're investing. So now let's try using the compound interest formula a different way. Here Matt is still saving for a new car. He's still investing $5,000, and he's still investing it into an account that pays 3% interest per year and is compounded monthly. But what we want to know now is how long will it take for his investment to double. So in this problem, we're looking for time. But that's okay, we're still going to use our compound interest formula. A is equal to P times 1 plus R over N to the NT power. Here we know what P is. P is equal to 5,000. R, that's equal to 0.03. N is equal to 12 because we're compounding monthly. We don't know T, that's what we're trying to solve. So we're going to need A. Now A is $10,000 because we want our investment to double. So whatever we started with, 5,000, if you double that, that's 10,000. If we plug all this in, we'll have 10,000 is equal to 5,000 times 1 plus 0.03 over 12 to the 12t power. Now this time, here we have an exponential equation with our variable t in the exponent. So if we're going to solve this, we're going to have to isolate this exponential term alone on one side. Now the first thing I'm going to do is simplify what's inside these parentheses a little bit. So we're going to have 10,000 is equal to 5,000 times, now 0.03 divided by 12, that's 0.0025, so this is 1.0025 to the 12t power. Now that I've simplified this, I'm going to isolate it, so I'm going to divide both sides by 5,000. Then I'll end up with 1.0025 to the 12t power is equal to 10,000 divided by 5,000, that's 2. Now that I've isolated this, I'm going to have to take and convert this expression into a logarithm because I have to get this variable out of the exponent. If I do this, I'm going to take 12t and make it equal to the log with a base of 1.0025 of 2. Now this is going to be difficult to take the log of, so I'm going to use the change of base formula, and I'm going to say that 12t is equal to the common log of 2 over the common log, or the log base 10, of 1.0025. Then I'm going to divide both sides by 12, so t is equal to the common log base 2 over 12 times the log of 1.0025. If you calculate this out, t is equal to 23.13. Now we're paying this interest per year, so this is in years. So being compounded monthly at a rate of 3% per year, it would take 23.3 years to double your money. Now let's look at one more example problem. Here Matt is planning to buy a car in 3 years. He wants to invest $5,000 now and hopes to have $6,000 to spend on the car when he buys it. So what kind of interest rate would he need if his investment is compounded monthly? Once again, we're going to use our compound interest formula. This is A is equal to P times 1 plus R over N to the NT power. Here we know what our final amount is. A is 6,000. Our initial investment P is 5,000. And we know our time, T, that's 3 years. And we're compounding monthly, so N is equal to 12. Plug all this in, and we end up with 6,000 is equal to 5,000 times 1 plus R is what we're looking for over 12, because N is 12, to the 12 times 3 power, because time is 3 years. So we have 6,000, and that's equal to 5,000 times 1 plus R over 12 to the 12 times 3 power, or the 36th power. Now I got to get to this value of R, so I'm going to divide both sides by 5,000. 6,000 divided by 5,000 is 1.2, so this is equal to 1 plus R over 12 to the 36th power. Now I'm going to raise both sides of this equation to the 1 over 36th power, or the 36th root. If I do that, I'll have 1 plus R over 12 is equal to 1.2 to the 1/36th power, which is equal to 1.00508 approximately. Subtract 1 from both sides. We'll get R over 12 is equal to 0.00508. Multiply both sides by 12. And we'll get R is equal to approximately 0.061. Or we can say 6.1 So Matt's account has to have at least a 6.1% per year interest rate. Now, the next thing we have to talk about is continuously compounded interest. This is when our interest is not compounded daily, monthly, weekly, yearly. It's always being compounded, or it's continuously being compounded. And that formula looks just like the compound interest formula. Instead of having 1 plus r over n as our base, we use the base e. So our formula is a is equal to p times e to the rt. A is our future value still, p is still our initial investment or our principal, r is still our interest rate, and t is still time. So again, let's look at an example. Lindsay invests $1,000 into an account with 4% per year continuously compounded interest. How much will she have after 10 years? And how long will it take her investment to double? Well, we have two different questions here. First, let's look at how much she will have after 10 years. A is equal to P E R T. We're looking for A after 10 years. So our future value A is equal to our principal or our initial investment of 1,000, which is P, times E. E is our natural constant. It's equal to about 2.718 to the power of R, so 0.04, 4% in decimal form, times T, which is time, so 10 years. So we have A is equal to 1,000 times E. Now 0.04 times 10 is the 0.4 power. E to the 0.4 power, that's about 1.4918. Multiply that by 1,000, and the future value would be 1,491 and about 82 cents. So if her account is continuously compounded at 4% per year, her final account balance after 10 years is $1,491.82. Now let's work on the second half of this problem. How long will it take for her investment to double? Well, again, we're going to use our continuously compounded interest formula where A is equal to P to the ERT. We still have the same P, we still have the same interest rate R. And now we know A instead of T. A is our final value and our investment is supposed to double. So A is going to be equal to 2,000. So this is going to look like 2,000 is equal to 1,000 times E to the R, or the 0.04 T. Now here I have an exponential equation with my variable in the exponent. So I'm going to solve this just like I would any other exponential equation. I'm going to isolate my exponential term by dividing both sides by 1,000. If I do that, I'll end up with 2 is equal to e to the 0.04t. Now to get this variable out of my exponent, I'm going to rewrite this as a logarithm expression. Now my base is e, so this is going to be a natural logarithm expression. So I'm going to say that the natural log of 2 is equal to 0.04t. Now that my variable is out of my exponent, I can solve for t. I just divide by 0.04 on both sides. And I get t is equal to the natural log of 2 over 0.04. If you calculate this out, you'll see that t is equal to approximately 17.3. Now we're paying 4% per year, so this is 17.3 years. So it takes a little bit over 17 years for Lindsay's investment to double. So now let's look at another example. Here Tony and Matt both invest $5,000 into an account that receives 3% interest annually for 10 years. Tony invests in an account that is compounded monthly. Matt invests in an account that is compounded continuously. So who made the better investment? Well, first let's calculate how much money Tony's going to have. His is compounded monthly. So we're going to use the compound interest formula that looks like A is equal to P times 1 plus R over N to the NT power. Now here for both of them, P is equal to 5,000. R is equal to 0.03 and T is equal to 10 for 10 years. If we plug all this in, we'll have A is equal to 5,000 times 1 plus 0.03 over N. N is the amount of times that Tony's account is compounded, and that's monthly, so 12 times per year. And that's to the 12 times T power, or 12 times 10 power. So, if we simplify this, this is 5,000. 0.03 over 12, that's 0.0025, so 1.0025, raised to the 12 times 10 power, or the 120th power. If you raise that to that power, that's equal to 1.349. Multiply that by 5,000, and Tony's final amount would be $6,746.77. Now let's figure out how much Matt will have. This is continuously compounded, so we're going to use the formula A is equal to PERT. A is what we're looking for. That's equal to 5,000 times E to the 0.03 times 10 power. So A is equal to 5,000 times E to the 0.3 power. E to the 0.3 power, that's 1.3499. Multiply that by 5,000. And Matt's final amount will be $6,749.29. So who made the better investment? Well, Matt did, by about $3. Generally, the more you compound your interest, the more money you will make up. Compounding continuously is the most amount of times that you can compound your interest, because you're always compounding your interest when you compound continuously. So compounding continuously is the best investment you can make. Now the last thing we're going to talk about are effective rates of return. Effective rates of return are simple interest rates that we calculate or are equivalent to rates that are compounded. Because when you compound interest, you end up with more money than you normally would if you just calculated simple interest. So let's look at an example here. If $2,500 is invested at 5% compounded monthly, what is our effective rate of return? And then let's compare that to the effective rate of return if this investment is compounded semi-annually or twice a year. Well, first let's find out how much interest we would earn in 1 year if we invest this $2,500 at 5% compounded monthly. So we're going to use our compound interest formula. A is equal to P times 1 plus R over N to the NT power. Here N is equal to 12 because we're compounding monthly. R is equal to 0.05, 5%. P, our principal, is $2,500. So we have everything we need to calculate our final amount. That's equal to $2,500 times 1 plus 0.05 over 12 to the 12 times 1, because we're doing this for 1 year, power. So A is equal to 2,500 times now 0.5 over 12, and then plus 1. This is equal to 1.00417. And this is raised to the 12th power. That's equal to 1.0511. Multiply that by 2,500. And our final amount is $2,627.90. So how much interest did we earn in that 1 year? Well, if we subtract our original amount, we'll see that we earned $127.90 in interest. So let's compare that to a simple interest formula. Remember, a simple interest formula looks like I is equal to PRT. Well, we earned $127.90 in interest on a principal of $2,500. We did this in 1 year, and we want to find our effective rate of return, or the effective interest rate that would have been a simple interest problem, not a compound interest problem. So 2,500 times R times T, but again, T is just 1. So here we have 127.90 is equal to 2,500 R. Divide both sides by 2,500. And our interest rate is 0.0512, or approximately 5.12%. So our effective rate of return at 5% compounded monthly is really 5.12%. Now let's calculate our effective rate of return if this investment is compounded semi-annually, or N is equal to 2. Our principal is still 2,500, our interest rate is still 0.05, and T, we're still doing this for 1 year, so T is equal to 1. Plug all this in. A is equal to 2,500 times 1 plus 0.05 over 2 this time, all to the 2 times 1 power. 0.05 divided by 2 is 0.025. Add that to 1, and this is 1.025. Raise that to the 2 times 1 power, or square it, and then multiply that by 2,500. 1.025 squared is approximately 1.050625. Multiply that by 2,500. And our final amount is $2,626.56. Now we need to find what our effective interest rate, or our effective rate of return, if this had been a simple interest problem. So I is equal to PRT. Our interest is the final amount we have minus our initial investment, which in this case our interest is $126.56. So I is $126.56. Our principal is still $2,500. Our R is what we're looking for, and T is still equal to 1. So R is equal to 2,500 dividing 126.56. If we calculate that out, we get 0.0506. So our effective rate of return, if we're compounding semi-annually, is 5.06%. So compounding more often raises our effective rate of return. And now that we've talked about effective rates of return, that completes our tutorial on compound interest.
So, okay. As you can see a while ago, no, some problem, no, give you a different way. Now we'll be able to solve, no. It depends upon to the thing that we need to look into. Let's say, for example, if we're looking to time, no, we will be able to have an example, no, even let's say, for example, for principal, no, for compound interest and so on and so forth. So most commonly, no, we have a way on how we'll be able to compute no compound interest, no. And compound interest is calculating by multiplying the initial principal amount by 1 plus the annual interest rate raised to the number of compound periods minus 1. And the total initial amount of loan is then subtracted from the resolved value. Okay, so we have, of course, the compound interest calculated on the initial principal, which also takes into account all of the accumulated interest of previous periods of a deposit or even a loan. So again, compound interest, the total amount of principal and interest in the future or future value na tinatawag in less principal amount of present or present value. So again, because compound interest includes interest accumulated in previous period, it grows of an ever accelerating rate. So in the example as what we discussed or as what we viewed, no, and even our presenter give us a way on how we'll be able to understand the interest payable at the end of each year, no, as what presented, no. Interest can be compounded, no, on any given frequency, no, from daily to annually. There are standard compounding frequency schedule that are usually applied to financial instrument, no. So the commonly used compounding schedule for saving accounts at bank is daily. For a certificate of deposit, yung CD na tinatawag nila, typically compounding frequency schedule are daily, monthly, or semi-annually. For money market accounts, it's open daily. So for home mortgage loans, home equity loans, personal business loan, or credit cards account, the most commonly applied compounding schedule is monthly. I'll repeat. The commonly used compounding schedule for saving as account at bank is daily. For a certificate of deposit, typically compounding frequency schedule are daily, monthly, or semi-annually. For money market accounts, it's open daily. For home mortgage loans, home equity loans, personal business loans, or credit card accounts, the most commonly applied is compounding schedule is monthly. There can also be variation in the time frame in which the accrued interest is actually credited to the existing balance. No, interest on an account may be compounded daily but only credited monthly. It is only when the interest is actually credited or added to the existing balance that it begins to earn additional interest in the or in the account or in their account, because some banks also offer something called continuously compounding interest, which adds interest to the principal at every possible instant. No? For practical purposes, it doesn't accrue that must more than daily compounding interest unless, no, you want to put money in and take it out the same day. So more frequent compounding of interest is beneficial to the investor or creditor. Again, more frequent compounding of interest is beneficial to the investor or creditor. For a borrower, the opposite is true. Okay? So in compounding periods, when calculating compounding interest, the number of compounding periods makes a significant difference, because the basic rule is that the higher the number of counting periods, the greater the amount of compound interest. Again, when calculating compound interest, the number of compounding periods makes a significant difference. The basic rule is that the higher the number of compounding periods, the greater the amount of compound interest. Okay? So, actually, we have also what we call special considerations na like compound interest is closely tied to the time value of money in the rule of 72, both important concept in investing. We have also what we call time value of money consideration. Understanding the time value of money and the exponential growth created by compounding is essential for investor looking to optimize their income and wealth allocation. Okay? So, yung sinasabi ko naman kanina, rule of 72 consideration, the so-called rule of 72 calculates the approximate time over which an investment will double at a given rate of return of investment. Let's say I, and it is given by 72 divide I. It can only be used for annual compounding. No, so as an example, let's say an investment that has 6% annual rate of return will double in 12 years. So an investment with an 8% annual rate of return will thus double in 9 years. Something like that. Now, we have also what we call compound annual growth rate, yung CAGR. So, the compound annual growth rate or yung CAGR is used for most financial applications that require the calculations of a single growth rate over a period of time. Let's say, your investment portfolio has grown from 10,000 to 16,000 over 5 years. So, what is the CAGR? No? Essentially, this means that PV is equal to 10,000 and FB is equal to 16,000 at T is equal to 5. So, the variable I has to be calculated using a financial calculator of Excel. It can be shown that I is equal to 9.86% actually. So, according to the cash flow convention, your initial investment PV of 10,000 is shown with a negative sign because it represents an outflow of funds. Okay? Yung first present value and future value must necessarily have opposite sign to solve for I in the given equation. Okay? So actually we have also a CAGR real life application, because the CAGR is extensively used to calculate returns over period of time for stock naman to. Yun yung mga mutual funds and investment portfolio. Okay? So again, ano nga ulit yung CAGR? Compound annual growth rate. Okay? So the compound annual growth rate can also be used to calculate the expected growth rate of investment portfolios over long period of times, which is useful for purposes such as saving for retirement. Na yun ang mga ginagamitan. So CAGR are often used the measurement economic data. Okay? So yun ang gamit. Now, this will be the last discussion of the compound interest. Maybe you're asking what will be the pros and cons of compounding. Ano nga ba ang advantages and disadvantages of compounding? A while ago, I've mentioned about miracle of compounding. So, through the miracle of compounding has led to the apocryphal story of Albert Einstein, calling it the ninth wonder of the world or man's greatest invention. Compounding can also work against consumers who have loans that carry very high interest rates, such as credit card debt. Again, a credit card balance of 20,000 carried out an interest rate of 20% compounded monthly would result in a total compound interest of 4,388 over 1 year or about 365 per month. Imagine that for 20 pesos for a credit card debt. Now, so on the positive side, syempre may advantage naman yan. On the positive side, compounding can work to your advantage when it comes to your investment and can be a potent factors in wealth creation. Exponential growth from compounding interest is also important in mitigating wealth eroding factors such as increase in the cost of living, inflation, and reduced purchasing powers. For mutual funds, often offer one of the easiest way to investor to reap the benefits of compound interest, opting to reinvest dividends derived from the mutual fund results in purchasing more shares of the fund. So more compound interest accumulates over time, and the cycle of purchasing more shares will continue to help the investment in the fund grow in value. So we can consider a mutual fund investment open, let's say for example, with initial 5,000 and an annual addition of 2,400. So with an average annual return of 12% over 30 years, the future value of the funds is, imagine, 798,500. So the compound interest is the difference between the cash contributed to an investment and the actual future value of the investment. Okay, so in this case, as what I mentioned earlier as an example, by contributing 77,000 or accumulated contribution of the 200 per month over 30 years, no, compound interest is 721,500 of the future balance. Of course, earning from compound interest are taxable. Take note of it, unless the money is in a tax sheltered account. So we need to understand all some financial technicality, because again, as I mentioned earlier, earnings from compound interest are taxable. If you visited your savings account, actually in your let's say you have a mobile application ng BPI. Let's say for example, if they give you an interest, automatically they also deducted a tax, So again, but we have what we call tax sheltered account. It's ordinarily taxed at the standard rate associated with the taxpayer tax bracket. Now, the tax interest investment, an investor who opts for a dividend reinvestment plan, yung DRIP na tinatawag, ito naman yung dividend reinvestment plan or DRIP, within a brokerage account is essentially using the power of compounding in whatever they invest. So investor can also experience compounding interest with the purchase of a zero coupon bond. Yung bond na traditional bond issues provide investor with periodic interest payment based on the original terms of the bond issue. And because these are paid out to the investor in form of a check, interest does not compound. Zero coupon bonds do not send interest checks to investor. Instead, this type of bond is purchased at a discount to its original value and grows over time. Zero coupon bond issuers use the power of compounding to increase the value of bond so it reaches its full price of maturity. So compounding can also work for you when making loan repayments. So making half your mortgage payment twice a month, let's say for example, rather than making the full payment once a month, will end up cutting down your amortization period and saving you a substantial amount of interest. So we have a different way on how you'll be able to compute, using in Microsoft Excel actually in calculating compound interest, So I think that's it, If you ask me, Doc, who benefits from compound interest? Maybe somebody, you have in mind, who benefits from compound interest? Simply put, compound interest between investors, but the meaning of investors can be quite broad. Banks, for instance, benefit from compound interest when they lend money and reinvest the interest they receive into giving out additional loans. Depositors also benefit from compound interest when they receive interest on their bank accounts, bonds, or other investment. Again, it is important to note that although the term compound interest includes the word interest, so the concept applies beyond situation for which the word interest is typically used, such as bank accounts and loans, So another business minded, Doc, can compound interest make you rich? Yes, in fact, compound interest is arguably the most powerful force for generating wealth ever conceived. And there are records of merchants, lenders, and various business people using compound interest to become rich for literally thousands of years. No, in the ancient city of Babylon, no, for example, clay tablets were used for 4,000 years ago to instruct students on the mathematics of compound interest. No, in modern times, no, Warren Buffett become one of the richest people in the world through a business strategy that involved diligently and patiently compounding his investment returns over long period of time. It's likely that in order or in one form or another, people will be using compound interest to generate wealth for the foreseeable future. So, okay, I think that's it. Again, at compound mean refers to ability of sum of money to grow exponentially over time by the repeated addition of earnings to the principal invested. Okay, so the effective annual interest rate is the return on an investment on the rate owned the interest of a loan when compounding is taken into account. Okay, so actually we have also what we call discrete compounding, no? So this refers to the method by which interest is calculated and added to the principal at certain set points in time. So I think that's it for this topic.